Hey everybody, hope you're doing well. Today we're going to go over working with material layers and material layer blend assets in C++ and how you can just in general get introduced to working with these. There's not a whole lot of resources for this particular workflow. So if you have tried to do that or say you were having some difficulty, this should help kind of bring some light onto that. And this particular tutorial is focused around people that are working as a TA or interested in being a TA or a TD and have at least some C++ experience. This would probably fall more on the upper beginner, lower to mid intermediate, or if you are even just at a more expert level, I suppose, and you just haven't really worked with these and you haven't had to, this in general could ease that introduction to it. So before we actually jump in and start writing some stuff, I feel a little primer on my background is in order. I've been working in the VFX and the games industry for the past decade. At this point, I've worked as a pipeline TD, as a professor. I've worked in tech art. I've worked in tech anim. I've worked in a very wide range spanning from Unreal, Maya, standalone stuff. So it's been all across the map with a big focus on pipeline-based stuff. And today's tutorial will really kind of be in line with that, with it being more focused on something you might see in a games or a VFX pipeline. And really the tool we'll be using will be more so a vehicle for discussing and going over working with material layers and material layer blends in an editor kind of respect. So by the end of this, I would expect you to feel pretty comfortable working with material layers and material layer blends in C++ when you're writing stuff for the editor. And if you don't, I will also in the description include a GitHub repo link to the source code of the plugin I'm writing on my side today. But that being said, let's jump into the editor. Okay, so now in the editor, I'll give you guys a short little demo on what you can expect to have. So as far as the assets I do have on my end, you can see here, I have a few material instances. These are all duplicates of one another. They're all using the same parent material. So if I open one of these up, you'll see this is a layered material with a background layer, as well as a grunge and a wetness layer with their respective blend assets. So on their respective blend assets, I do have mask parameters, and that's what I'm gonna be writing this specific tool for, though you can very easily extend the tool and you can kind of run with it. You can do quite a bit of stuff with it. If I say wanted to change the particular mask being used on those blend assets, if I right click, come up to our scripted asset actions and go ahead and try to replace this stuff, specifying the parameter name of mask. If I were to say select a random noise and hit OK, you'll see that what the tool we're making today is going to do is go through, and on each of these blends, it's going to replace the mask parameter with the specified texture. And again, the whole point of this video is not to give you an out-of-the-box tool that you're going to use to like solve world hunger. We're really just trying to get comfortable with layers and layer blends. Let's now jump over into Rider and let's get started. So step one, we're going to go through and I'm going to just make an empty plugin. So I'm going to right click on my plugins folder, hit add, and then come down to Unreal plugin. And then from there, we can give this guy a name. So this will be material layer editor, we can maybe call it. We'll keep it blank, and I'm not going to fill out the rest of these aside from adding the plugin reference to the actual like game module. So I'm going to go ahead, right click, and let's add a new Unreal class. So I'll actually name this object. So I'll go ahead and do uObject, and I'll make this public. And we'll go ahead and hit OK. So the one fun thing about working with the material layers and material layer blend system is that under the hood, a material layer and a material layer blend are really just material functions with a nice wrapper around them and some nice exposure in the interface. So what we're actually going to be doing is just setting parameters on the material instance itself and specifying that, hey, this is a parameter on a material layer or a material layer blend, as opposed to, say, getting a reference to our material layer or our material layer blend and setting that stuff individually. So as opposed to including the material functions material layer, I am just going to have to include material instance. And then if you were going through this individually, like on your own, you'll see the delineation between material instance constant and material instance dynamic. The main difference between the two is whether you're working in an editor capacity or a runtime capacity. So if you're wanting to edit a material instance U asset like in the editor and not at runtime, we're going to be working with the constant, as it is the thing that does remain constant, and then a dynamic one is something that can change at runtime. So I'll go ahead and include material instance constant. And then coming down from there, we can actually start to declare some of our functions. So I'll come down from generated body and I'll specify that we're going to be working in the public section of this class. At least for the purpose of this, I'm just going to write everything inline so it's a little more clear as we're going through the writing of this tool. So I'm going to have this be a inline static, and this function will return a Boolean of whether or not it succeeded in switching that particular parameter. And this will be, and as I had mentioned earlier, we do know that this is going to be actually doing this function on the material instance itself. So this will be passed in a uMaterial instance constant, and this will be a pointer. And then from there, we're going to take in the name of the parameter we're going to be changing. So maybe an f name, and we'll pass this by reference to avoid copying parameter values over and over. So this will be the parameter name. And then we'll also take in the new uTexture 2D value that we do want to set. So we'll do uTexture 2D, and this will be a pointer to the new texture. So just to get rid of this red text, since we're not currently returning, I'll return false at the very end. So before we actually go about switching this parameter value, we first definitely want to check to see if it actually exists already on the material instance. So let me go ahead and access my material instance, and then the function we're going to be using to check that is get texture parameter value. And then this texture parameter value is going to take in an f-hashed material parameter info. And even though it says it takes in a hashed material parameter info, we're just going to be using the unhashed one, and then it can convert natively to that. So let's declare our parameter info struct to pass in to just give a description of what parameter we are trying to get. And inside of this particular struct, this will be where we determine whether or not we're trying to access a layer or a layer blend, or if we're just trying to access a global parameter on that particular material instance. So let's do an f material parameter info struct definition, and we can call this parameter info. So if we take a look at what we actually need on the parameter info, so you'll see this takes in an e material parameter association, so an enum value. So if we take a look at this enum, we'll see that this lets us specify whether we're looking for a layer parameter, a blend parameter, or a global parameter. So knowing that, we can go ahead and set our association equal to blend parameter. Now we can go ahead and specify the name. We're going to set name equal to parameter name. So this index is the layer or blend index in that layer parameter stack. So this could change based on which material instance you're actually in. You could have 12 layers, you could have 5 layers, you could have 1. We need to be able to dynamically change all these parameter values no matter how many layers it has. So for this index, I'll just for now set it to 0. So if we access our material instance, we do have access to get all texture parameter info. And what this does is it allows us to pass in by reference an array of parameter info structs, and then it will fill that out with all the texture parameter infos. Before that call, I'm going to declare a T array of F material parameter infos, and then it does also take in an array of F GUIDs. So we do also need to pass in an array of those. So now this will fill our list with all of our texture parameter infos. So let's do for each F material parameter info. And we'll do this by reference because we don't want to create copies of each info as we iterate. And we'll be looping over the instance texture parameters. So I'm only going to want to do anything with the particular info for the current iteration if it matches the specific parameter association as well as the name of what we've passed in. So from here, I will do if info.name equals parameter name, and then we'll also if info.association is equal to blend parameter. So if the particular info for the current iteration matches our parameter name and matches our association that we're trying to look for, so if it's a blend parameter, then this is where we would actually want to be able to do something with this. So before we actually go ahead and update the parameter value, I'm going to first check to see if the texture that's already set matches what we're trying to set it to. So let me bring this get texture parameter value call up here. So we're going to pass in our info for the current iteration since it matches the name and the association that we're looking for. And then we do also need to pass in a uTexture pointer. And this will be the current texture value. So we'll go ahead and pass in the current texture value. So before I go ahead and actually set the value of this parameter blindly, I'm first going to check equality to make sure that this current texture value isn't already equal to what we're passing in as our new replacement to avoid any unnecessary assignment that we don't have to do. So to do that, I'll do if, and then instead of casting this uTexture to a uTexture 2D, I'm instead going to cast this texture down to a uTexture. So if we do go ahead and hit Control B inside of Rider to go and look at the source of uTexture 2D, it inherits from uTexture, so it can therefore be casted safely down to a uTexture. So we'll do if the current texture value, and then I'm going to do a not equal is not equal to cast checked uTexture So from here, I can now go ahead and actually set the value of this. So I'll get my material instance, and I'll go ahead and do a set texture parameter value, and then we're going to do editor only. And then here, I will give it my parameter info. And then I'll also give it our texture that we passed in as a parameter. I can now safely get rid of this top part. This texture, since we do know that we're going to be wrapping a editor action around this, we could potentially pass null into this. This is definitely something that could happen, so it's always best to first check and make sure if texture, we'll actually do if not texture. So if it's not a texture, we will return false. And then we'll do some logging. and we'll just log temp for now. Actually, let's log temp. So now that this one's done, we can go ahead and actually get onto the editor action portion of this and start testing this in the engine. So let me collapse that. And then now for the editor utility action, I'm going to go ahead and create a new class. And you may actually want to, in your public, add a directory. And I'm going to name this actions. And then inside of actions, I'm going to add a new Unreal class. And this will be of type UAsset utility action, or UAsset action utility. I'll name this material blend actions. And this will be public. Go ahead and hit OK. So I'm going to declare our constructor. And this is going to be where we update and add our supported classes. Inside any asset action, we're going to want to specify the classes that are supported. So if we're wanting to run material blend actions, we aren't able to right click on a blueprint and try and run this action. So I'm going to append to the supported class list. So supported classes, we'll go ahead and do an add. And then from here, we're going to do a soft class pointer. So that way we're not loading a full reference into memory to be able to check compatibility. So T soft class pointer, and this will be to a U material instance. Got it. And that's all we'll have to do there to be able to specify that we just want to work with these classes. So now we can go ahead and actually define the function that's going to call our material like blend switching function. So in the public section, we're going to want to do an inline void. It'll be replace blend mask parameters. And this is going to be, we're going to have to specify that this is a U function. This needs to be callable in the editor, and then I do also make it blueprint callable. So we'll do call in editor and blueprint callable. And this is just to make it so that we can actually, when we're inside the editor, right click and it will specify this function in that list for us. Since we are in the utilities taking in a parameter name and a texture, I'll just go ahead and copy this. And we're going to want to specify that we're taking in those parameters inside of our action, so that when we do actually call this action, it'll prompt for us to give it value. So from here, I'm now going to want to include our material layer utilities header. So let's do include material layer utilities. And then from there, we're going to want to call our... So before we actually go about calling this, we do need to get access to the material instance we have selected in the content browser. So to be able to actually access the content browser, get our selection, parse through, and get the material instances that we do have selected, we're going to have to include two modules, which are the content browser module, which holds utility functions for the content browser, and the iContent browser singleton, which is the actual class that runs the single instance of the content browser inside of the engine. So for those, it's going to be include content browser module.h and include iContent browser singleton.h. From here down in our function, we first need to actually load the content browser module. So we're going to declare an f content browser module, and this will be a reference, and I can name this content browser module, which will be equal to, and then we're going to have to load this module. So we'll load this through the f module manager, statically access load module checked. And this function is essentially just going to load the module of the given type and name. So from here, this will be an F content browser module. And then the string we're going to be passing in, so the module name is content browser. And this here will now successfully load our content browser module. Let me spell that correctly, maybe. And the first thing we're going to be doing is now getting the I content browser singleton. And this will additionally be a reference, and I'll name this content browser, keep misspelling it the same way, browser singleton. Then all we're going to do now is from the content browser module do a .get, which returns to us the singleton version of the content browser. So off the content browser singleton, we can do a get selected assets. So this is going to take in by reference an array of asset data, which we pipe in to be able to have it populate that. So before we actually make this call, we need to first declare a T array of F asset data. And this will be our selected assets. So let's go ahead and pass that in. What I'm going to do is iterate over all the selected data, and for any material instances, I'm going to run this action. So let's do for, and then this is going to be for each asset data inside of our selected assets. So now we can iterate over our asset data, and then from there we can check to see if the particular asset is a material instance, and if it is, run our function. We're nearly there. We're 85% of the way there. So if I go to access the asset data, you'll see we have get class, get asset. So the get asset returns a pointer to the U object, which sounds nice in theory, but say theoretically, if you were to select 100 different assets and try to run this action, it would then have to load each one of those into memory before you even evaluate to see if it is the correct class type. So instead of doing that, we're going to use the asset class path, which returns a unique path to that particular class there. So what we'll do here is if the asset class path is not equal to, and then we're going to check it against a uMaterial instance to get the class path of a particular asset type. We're first going to have to get the statically generated class, so the internal class generated by Unreal's reflection framework. So say like your generated body, we'll insert that static class, and then from there we can get the class path name and check equality between these two. So now without loading an entire U object into memory just to check equality, we can check to see if this particular asset even is a material instance. So if it's not a material instance, I'm just going to go ahead and continue. So safely, if we pass this if statement without entering, we're now accessing a uMaterial instance piece of asset data. So now what I'm going to go ahead and do is get the actual asset U object itself, cast to a uMaterial instance, and then from there we will run our function. Then we can go ahead and get in the editor and start testing this. So I'll wrap this in an if. So if uMaterial instance pointer, I'll name this material instance, is equal to cast checked, and this will be a uMaterial instance. And then we'll, on our asset data, pipe in the asset. So we'll use get asset to return that U object pointer which will then get casted to our material instance. And now I can go ahead and run our function at this point. So I am here going to give it a reference to our material instance. And then I'm also going to give it our parameter name. I'll give it our texture. And you can now see we're getting a little bit of an error, and that's because we're not casting to a material instance constant. So let me just go ahead and add that. Okay, now we should be all good. You may ask, why are we able to cast to a material instance constant when up here we're only checking to see if it's a material instance? And that is due to the fact that a material instance constant and a material instance dynamic, a material instance can natively cast to either of those. So it is a little dependent on whether you're in the editor or not, but a constant just represents the actual asset that is that material instance, where the uMaterial instance dynamic is the class you would cast to if at runtime you're wanting to make changes to that material. And those changes are naturally transient, so once you exit the runtime, it's no longer going to be there unless you decide to actually bring that down to the material instance constant. So a material instance itself is represented by both of those. It's just a matter of what scope you're in and where you're actually executing and how you're wanting to execute that. So to avoid any unnecessary getting of the content browser, we're going to check if we're given an invalid texture. We're going to go ahead and return. And then that will safely save us any unneeded processing. And now we should be good to go ahead and build. So we're going to build in debug, and let's see if we run into any errors. If we do, my guess would be unresolved externals, because I have not touched the build.cs. So it does look like we ran into a couple of errors here. Cannot open include file, editor utility object.generated.h, no such file or directory. And for this, I have not touched the build.cs file yet in this tutorial, so it wouldn't be expected for it to already know where to find that stuff. So I'm going to go ahead and go into demo. I'm going to go demo, and then I'm going to open up my project, go into plugins, and then I'll go into material layer editor, the name of my plugin. From there into source, and then we'll open up the material layer editor.build.cs. So to be able to actually work with the content browser and asset actions, we're going to have to add to our dependency list the content browser, believe it or not. And then from there, we're also going to want to include the Blutility module, which this is the one that does include our editor actions. Okay, so now we're good to build. And then I'll catch you guys back once this does build. My computer's a little bit slow. So it looks like our build was a success. Let's just let the editor finish loading and initializing. So if I go ahead and right click my material instance, you'll see I'm not having any scripted editor actions pop up. And that's because we do actually need to load that into the editor. So I'm going to come into the root of my content folder. I'll go into pipeline, and then inside of here, don't mind the interchange folder. That's just foreshadowing of what's to come. I'm going to go ahead and add a new folder, and I'll call this actions, or you could just do action. I personally prefer to not pluralize my folders because it's like a folder for an action. Therefore, it's going to hold actions inside of it. Just a personal preference. I'll die on the hill, but hey, it's whatever. So inside this actions folder, I'm going to go ahead and right click, and then I'm going to come up to blueprint class. I'll look up material blend, and here we can see our material blend actions. Go ahead, select, and create that class, and I'll name this material blends actions, or material instance actions. And then I'll go ahead and double click on this to open it up. And then this will load this asset into memory. And now our scripted action will be populating on that menu, so long as we did everything else correctly. So inside of here, you can tick on run on startup. So each time you start the engine, it will automatically load this into memory and populate your scripted actions. But now if we go back over to our material folder, let me clear the log. I'm going to go ahead and right click. And it looks like we have our scripted asset action on here now. So let's go ahead and give that a click. So the name of that parameter was mask. And then for the texture, I'll just look up noise. And I'll select some random noise, like maybe that one. And then let's go ahead and run our action. So it looks like it ran action on asset count 0 out of 1. See, it looks like it probably did not run that. It's funny. It's always the simple things. So the reason it was passing by is because I'm checking to see if the current texture is not equal to the passed in texture. And if they're not equal, I'm continuing. But I have it flip-flopped exactly what I'm even wanting to do. So I'm wanting to check to see if these two things are equal. So these two things are clearly not equal because I'm trying to change the texture that's being used there. But I'm continuing if they're not equal. So simple fix. So now let's try the asset action. So I'm going to right click on my example layered, do my replace blend mask parameter action. And then I want to replace any parameter with the name mask. And then if I look up noise for the texture, I'll go ahead and set it to this noise here. So the wind noise. So now if I go ahead and hit OK, you'll see that we actually have that updating now. So in our logging, we completed the layer blend texture update on 2 out of the 5 texture parameters inside of that particular material instance. And it ran the action on an asset count of 1 out of 1, so all the ones we had selected. And then now to verify that this will work across an array of different material instances, I'll select all of these, right click, come up to scripted asset actions, replace blend mask parameter. So anything with the name mask, parameter wise, I will switch this to the wind noise texture there. If I go ahead and hit OK, our logging denotes that we did successfully complete the layer blend texture update on 2 parameters across the 4 assets. So if I go ahead and save, you'll see here, now that successfully went through and updated the stuff. And it looks like we're coming up on time. I hope you guys learned something from the tutorial, whether you knew some of it, not some of it. Even if you learned all of it, I hope it helped in some way. I know when I initially dived into material layers and layer blends, there weren't too many resources in terms of stuff on the forums. It was really just source code is all you could really go through. So I do hope this found somebody that maybe doesn't feel as comfortable or just in general wanted that sort of quick guide on how to start working with this stuff. This is, of course, just the surface. There is a bunch more that you can do. So if you guys have any ideas or any things you want to know, just feel free to drop a comment. I'm more than welcome to take on new stuff, I suppose. And I will, of course, drop a link to the source code on my GitHub in the description, as well as some resources for layered materials. If you're not super familiar with them or haven't worked in a pipeline that leverages them extensively, I know you can do quite a bit if you are kind of at the ground level in a pipeline and you're able to set standards for things like names, and the team is wanting to kind of take a layered material approach for everything. This can do numbers to kind of free up artist time and them not have to spend so much time going through and replacing things like texture assets. So until next time, I've got to take off. I've got a meeting. I hope you guys have a good one and keep learning, keep coding. Don't stop.